Good morning. I am a master course student, Yunjin Kim, in the University of Science and Technology at South Korea. Today, I'm going to be talking about isolation and identification of secondary metabolites with TRPA1 inhibitory activity from the marine sponges. My presentation consists of introduction, material and methods, result and conclusion. First of all, I'd like to talk about the marine natural products. It is known that marine organisms produce a variety of secondary metabolites that are different from terrestrial organisms due to extreme marine environments such as high salt concentrations, high pressure, and low temperature. Since the 1960s, when marine natural products research began, more than 30,000 compounds with unique structures and diverse pharmacological activities have been isolated from the marine environment. In this figure, cytarabine derived from sponges was first approved by the FDA in 1969 for its excellent anti-cancer activity. From that time, marine-derived pharmaceutical materials have been developed for biopharma. Secondly, I'd like to focus on background of my research. TRPA1 is a calcium permeable non-selective cation channel activated by noxious chemical, mechanical, or thermostimuli. According to the animal experiment, TRPA1 is expressed in sensory neurons and non-neuronal cells such as epithelial cells and hair cells, and is involved in acute and chronic pain, inflammation. So TRPA1 is playing key roles in the pathophysiology of nearly all organ systems. Therefore, TRPA1 is attracting attention as a therapeutic target for related disease. Importance of TRPA1 in pain, inflammation, and many other potential indications in occurred disease triggered an increasing demand for antagonists. Most of the currently used TRPA1 antagonists are known to be synthetic compounds or natural products derived from terrestrial plants. Through this point, the objective of my research is discovering materials with TRPA1 inhibitory activity derived from marine organisms. For this, first we screened the 544 extracts of marine sponges for inhibitory activity against TRPA1 using a calcium mobilization assay. Among them, we selected two extracts which showed inhibitory activity of more than 50% in duplicate experiments. The table indicates that TRPA1 inhibition values of the selected sponges extract. Two selected sponges were collected by scuba diving from the Federated of Micronesia and the Philippines, and as a result of classification, based on morphological characteristics. There were identified genus Epipolysis and Stylisacea respectively. Both samples were performed using the same experimental method. First, sponges were cut into small pieces and then extracted using methanol and dichloromethane. Combined extracts were partitioned between normal butanol and water to eliminate salts, and then normal butanol layer was further partitioned between 50% aqueous methanol and normal hexane. After that, isolation of compounds was carried out using various chromatography techniques, and all chemical structure of the isolated compounds were identified by NMR and mass analysis. Here we found meaningful results. If you look at this spectrum, you can see that two different sponges with the same activity has the same major components. This is chemical structure of isolated compounds and their NMR spectrum. All structures were confirmed through comparison with literature, and all compounds were nitrogenous sesquiterpenoid derivatives. Last, I'd like to talk about TRPA1 inhibition activities of isolated compounds. Looking at the result, we can see that the compound 1 and compound 4 showed activities with IC50 value 13.5 micromole and 13.1 micromole respectively. In conclusion, 8 compounds were isolated from 2 different sponge extracts with TRPA1 inhibition activity, and all structure of the compounds were determined on the basis of NMR spectra, HRESI mass analysis. All isolated compounds were tested for TRPA1 inhibition activity, and as a result, compound 1 and 4 showed moderated activities. Thank you for listening.